System Analysis and Design. Group 2. The members are Aushi Fleming, Evrel Willams, and Zavon Pennyfeather. Here are the objectives that we will review in this video. 1. Apply knowledge of the stages information system development, such as problem definition, feasibility study, analysis, design, construction, testing, implementation, evaluation and maintenance to create a solution to real-life problems. 2. Describe the processes involved in prototyping. 3. Explain the stages of prototyping. 1. Apply knowledge of the stages information system development, such as problem definition. Problem definition. A system analyst is where one specifies a problem and recognizes the issue before making an effort to solve that problem. Example: I woke up and saw that my alarm clock never went off, so I've been starting my morning 15 minutes later than I've planned. It is a really important day at school and I cannot be late. I came to a conclusion that the batteries in my alarm was dead, so I replaced the batteries to fix the problem. Analysis. In this stage, this is where we deconstruct the different parts of the system. The aim of this stage is to gather data on how every component corresponds and functions with all other components. If there is any problem, the requirements of the system would need to be specified by the analyst, and different solutions will be put in place to be analyzed, and the most suitable solution will be executed. Design. A design shows a primary barrier facing the design process or hindering a desirable ideal solution in an organization. This creates a sense of possibility and optimism that allows an organization or team to input ideas and discuss scenarios and solutions. Construction. This is the result of all gathered ideas that you have and assemble them to keep an ongoing process to achieve a common goal. According to prototype, this is the semi-finished product or design. As the product is not totally ready for testing, the construction acts as a final assessment with most of the characteristics and design verification. Testing. This is the stage where we see how users would operate with the prototype. This can also help in finding new solutions to problems or to see if the whole project would be successful. Implementation. When the new prototype is created and tested, it must be implemented in the organization. There are 5 most popular implementations below. Direct cutover. In the direct cutover implementation methodology, the organization selects a particular date that the old system is not going to be used anymore. However, this method is the riskiest as well. If the new system has an operational problem or if the users are not properly prepared, it could prove disastrous for all the organization. Number 2, pilot implementation. In this methodology, a subset of the organization, called a pilot group, starts using the new system before the rest of the organization. This has a similar impact on the company and allows the support team to focus on a similar group of individuals. At number 3, we have parallel operation. Parallel operation, this is where the old and the new systems are being used at the same time for a limited period. This method is the least risky because the old system is still being used while the new system is essentially being tested simultaneously. At number 4, we have phase implementation. In phase implementation, this is where the different functions of the new applications are being used while the functions from the old system are being turned off. This approach allows an organization to slowly move from one system to another. At number 5, we have maintenance. This is the final phase that takes place once the implementation phase is completed. In this phase, the system has a structured support process in place. This is where bugs are reported and fixed, and requests for new features, system updates, and backups are performed on a regular basis. Maintenance. This is the final step, which includes regular required checkups and updates. This is also the step where end users can modify the system at their own choice to help enhance performance, meet additional user requirements, or even add their own new capabilities. Objective number 2. Describe the process involved in prototyping. What is a prototype? This is an idea or sample to test a model system that is in progress. Prototypes are put in place to help system designers build an information system that is understandable and easy to wield for end users. Why are prototypes important? A prototype is used to evaluate a new design to enhance precision and product effectiveness. Make informed design decisions. Identify issues and flaws in the design before it's too late. Gain first-hand insight into how users react and interact with the product. Objective number 3. Explain the stages of prototyping. Step 1. Requirements gathering and analysis. Requirement analysis is the first step in a prototyping model. The system's requirements are defined in detail during this phase. Ideas can also be transferred by customers to see if the project have any risky ideas. Step 2. Quick design. This is a design, also known as preliminary design, which is the second phase, however, not a finished design. It gives the user a quick overview of the system. The prototype development is guided by the quick design. Step 3. Build a prototype. The information gathered from quick design is used to create an actual prototype in this phase. It's a scaled down version of the required system. Step 4. Initial user evaluation. This stage determines the working model's strengths and weaknesses. Customer feedback and suggestions are gathered and forwarded to the developers. Step 5. If the user is not satisfied with the current prototype, the developers must improve it based on the user's feedback and suggestions. This phase will not be completed until all of the user's requirements have been met. A final system is developed based on the approved final prototype once the user is satisfied. Step 6. Implement, product, and maintain. The final system is thoroughly tested and ready for production after it was developed based on the final prototype. The maintenance routine is performed on the system to reduce downtime and prevent large-scale failures. Here are some of our references that were used during this research video. This is the end of our video presentation, and I thank you for watching.